we're going to discuss the concavity and the points of inflection for number 12. All right, so we need to find the second derivative, which means we have to find the first derivative first. So we have 6x squared minus 6x minus 12. That's our first derivative. Second derivative, 12x minus 6. Setting the second derivative equal to 0, I add the 6 and divide by 12, and I get x equals 1/2. Okay, so one possible point of inflection at 1/2. So I'm testing values from negative infinity to 1/2, and then 1/2 to positive infinity. All right, so let's do 0. 12 times 0 minus 6 is negative 6, which means that we're concave down. Okay, and I'll do 1 on this side. 12 times 1 minus 6 is positive, which means we're concave up. All right, so we have a point of inflection because the concavity changes at 1/2. So now we're going to plug 1/2 back into the original function, f of 1/2. All right, so we have 2 times 1/2 to the third minus 3 times 1/2 squared minus 12 times 1/2 plus 5. All right, so 1/2 to the third is 1/8, so 2 times 1/8. And 1/2 squared is 1/4, so 3 times 1/4. And then 6, or negative 12 times 1/2 is negative 6, and plus 5. So 2/8 simplifies to 1/4. 3 times 1/4 is 3/4. 1/4 minus 3/4 is negative 1/2. And negative 6 plus 5. All right, so we have negative 1/2 minus 6, which is negative 6.5, and then negative 6.5, let me add a room here, plus 5 gives me negative 1.5. So my point of inflection is 1/2, comma, negative 3/2, or negative 1.5.